Here we have homework number 20, and I think I forgot to write down the problem. I wrote down the problem now. All right, so the UHart Civil Engineering Club has this wedge with a little 5-degree angle. They're trying to move this concrete block that's 100 pounds up a 20-degree slope. The static coefficient of friction between the wedge surfaces is 0.4, and the static coefficient between all of the block and all the block and the incline is 0.7. So neglect the weight of the block and the wedge and determine the smallest force needed to move this thing. So I think we could probably get a little confused here about what the coefficient of friction is supposed to be by my miswording of this. The static coefficient of friction for both wedge surfaces is 0.4, and between all the block and the incline, I don't think it should be all the blocks, just the block. I think we should get rid of between the block and the incline, so there should be no all in there. So maybe I should try to fix that ASAP. I don't know, people probably already started their homework, right? So let me pause the video and see if I can fix that. I haven't had a question yet, so okay, so here we go. Let's do a little FBD action. Let's start with the block. Why not? And it's on a slope. Let's see, you get weight coming down. And see, I didn't put the angle in there. That angle is theta, and this angle right there is beta. Yeah. So let's see, this is theta, and this is the weight of B coming down in here. And let's see, I guess there's going to be a normal force right there, and a normal force right here. And there's going to be a friction force right there, and then this block's trying to come down, so there must be a friction force coming right there. Okay, so we have F N, what do you want to call this? This F N, I think maybe, call it AB, and we'll call this C, we'll call this D. Got to give it some names, right? And this will be BC. So this is going to be F BC, and this will be F AB. Why? Got nothing better to do. All right, so the coordinate system here will align X prime, Y prime. So the sum of the forces in the Y prime direction equals 0. And let's see what we got here. Excuse me. We're going to have, so this angle right here. Oh, we don't need any of those angles, do we? So we have in the Y direction, trying to think out loud here, we get negative WB times the cosine of theta. I got a negative F AB and a positive F NBC. Okay. We could put numbers into this. Wouldn't hurt anything to do that. This thing is going to be a long video because I'm not feeling very smart today. Feeling kind of sluggish. 100 cosine of 20 FFAB plus FNBC. And boom, maybe I'll solve for FNBC, because those are both negative right there, right? So that's going to be 100 times 20 cosine, boom. So 93.97 plus FFA. Equation 1. Now take the sum of the forces in the x direction. I said this did x direction. And the y prime direction. Y prime direction. That's right. And that's going to have, nope, just did the y prime direction. Whoa, I'm tired. I didn't eat dinner yet. I'm going to go eat dinner. Between this problem and the second problem. And let's see, looking at this in the x direction, you have negative. I wrote it out as variables up above, so I should be consistent. We'll write it as negative WB sine of theta, negative FFBC, and then a positive FNAB. Equals 0. Oh, I didn't post that thing. Why did I pause the thing and I didn't post it yet? Shove some numbers in here. 100 sine of 20 minus FFBC plus FNAB equals 0, and we end up with FNAB equal to 120 sine 34.20 plus FFBC. It's going to be interesting. All right, so that's equation 2. Can we find this other thing? That's what I want to know. Can we find, because we also know that FAB, let's start with AB, is equal to mu, and let me reread the problem. The problem says the static coefficient between the block and the incline is here. The static coefficient for both wedge surfaces. Okay, so this is going to be S wedge and times F N A B, right? Or 0.40. FFBC is going to be block FNBC, or 0.7 FNBC. All right, so can I stick any of these things in here? Okay, so let me replace interesting. So we have 1, 2, 3, 4. We have 4 equations and 4 unknowns. Let me sit here and I'll look at the thing off camera for a second. Okay, all right, so here what I did is I plugged these back up into each of these, right? These frictions into there, friction into there. And then that's what I did right here. And then now I am plugging this into there. And so once I put this in there, that should be FNBC. So now I should be able to get FNBC. So 93.97, 0.4 times 34.2. Add them together. And now I'm going to bring this over to that side. So it's going to be 0.4 times 0.7, but minus 1 right there. Or subtract that from 1 and divide that over here. And I say that this is 149.5, and these are pounds. Let's move my keyboard over to the side. And so therefore I have FBC, right, is this going to be 0.7 times 149.5, or 104.7 pounds. And then NAB FNAB, we could go down right to here, right? And take 34.20 plus 0.70 times 140. Ooh, wait a minute, I don't know if I like that. Yeah, okay. Yeah, that should work. So that's going to be just that plus the 34.2. Yeah, I think so. 34.2, 0.7, 149.7. Uh-oh. What happened to my calculator? No, well, the batteries in here dead. Uh-oh. Oh, dear. Oh, dear. That's not good. So, yeah, times and plus, so I got 138. Oh, 0.99, so let's say 139. 139.0 pounds. And so my FFAB is going to be 0.4 times my 139.0, or 0.4 times it, and I get 55.60 pounds. Okay. So we're ready to go to the next FBD, which is on the block. We have all of these things right here. I don't think I actually needed this surface right there. I think we could have actually solved this without that. So here, I can't wait to eat something. I'm really hungry. S21, ES110. I could fill this out later, but I'm still filling it out. What are you doing? I don't know. Okay, this is 1. Continued. And so let me draw my picture. Let's try to make it look similar here. Alright, so right, so here's where some of the difficulty lies. Got to make sure we get that angle in there. All right, so let me get this. This is P in here, and this is an FBD, so we got to write that down. And I think I am going to align this with the majority of the thing, right? So it's like this right here. It's still going to call this the prime. And so we're going to have, we know this, we were able to find this normal, which we called FNAB, and we know that value. And now the friction is in the opposite direction here as it was on the other surface, FAB. Okay, and now we're going to have a frictional surface that's also moving down, and that going to go that is resisting its motion. And then it's going to have one that is perpendicular right here, and we're going to call this FNAD. AD, and this is FFAD. All right, and so some of the forces in, there's not much we could do here. You gotta choose two equations and two unknowns, but probably in the x prime direction is the way to go. Some of the forces in the x prime direction equal 0. And so we're going to have a negative FNAB. We're going to have a positive FNAD, but let's see, let's draw them this way right there. That right there is going to be beta. And we also know that that right there is also beta. I don't want those to connect. All right. So, what direction is it going to go? That's the cosine of beta. And then this one is in the negative direction. The sine of beta equals 0. All right, so we know this value, but we also know in a relationship, I'll write it up here, that the FFAB, AD is equal to mu S, and this is the wedge, times FNAD. Or 0.4, yeah, FNAD. So when we put this FNAB, we have 139.0 negative, and then a plus FNAD cosine of 5 degrees minus 0.40 FNAD sine of 5 degrees equals 0. So we can find FNAD. Yes, 139, and we'll take the cosine of 5 and the sine of 5 times this, but we're going to subtract that out, and we'll divide that by that, and we get 144.6 pounds. And then sum of the forces in the y direction equals 0, y prime direction. Should have been aligned. I guess it's, yeah, it's aligned. Okay, just subtle. And we're gonna have a negative p we're going to have a positive FFAB, and we're going to have a positive FFAD cosine of beta, and we're also going to see, we're going to have a positive FNAD sine of beta equals 0. So P is going to be FFAB. Oh, by the way, we could figure this out right here. Maybe as an interim step. .4 times, I get 57.84 pounds. So let's see, FFAB was 55.60 plus FA, there's a 55.84 times the cosine of 5 plus 144.6 times the sine of 5, and I get P is equal to lots of things. Why did you write 55 when it's 57? I don't know. I don't know why I do the things I do. 55.6 plus, okay, and 144.6, but it's times the 5 there, so it's not going to be a lot of that. And we had 125.8 pounds. There's the answer. Ta-da! You don't care.